All right, so now we're going to talk about Unit 3, which is talking about increase and decrease in concavity and more things. But if something's increasing or decreasing, remember that's looking at what f prime is. F prime is positive, slope is positive, increasing, slope is negative, decreasing. If the second derivative is positive, concave up. Second derivative negative, concave down. Concave up looks like that, concave down looks like this. So it's how are we increasing or decreasing? Um, absolute min-max versus relative. Absolute maximum or minimum is the highest or lowest in the interval. Relative is any high or low. Critical numbers. Critical numbers are where the derivative equals 0 or the derivative does not exist. To check both those things, find all your critical numbers. Critical numbers are not always only mins or maxes. They could also be other parts. Um, EVT, we'll talk about extreme value theorem. EVT helps us to know that there is a max or min in an interval. The only thing we have to know is that f is continuous on a certain closed interval. If it is, then there is a min or max, absolute min or max. And it could be A or B itself. It could be the edge of it or the end point. Now we'll talk about possible points of inflection and points of inflection. A possible point of inflection is where the second derivative equals 0. But if it is a point of inflection, there has to be a sign change. Sorry about that. Keeps going out of the frame because that thing is terrible. Can't really set this up. As you can tell, I'm not in a very good mood right now because I've made these videos like 62 times and they always turn out bad because I have nothing that works anymore. I used to always use the iPad, but it works horribly now. Because it's acting like I have to buy a new one. So this might be the end of Jake and Nash, but whatever. Um, how do you find maxes or mins? Do the derivative. Set you find out the critical numbers. Set the derivative equals 0. Figure out where it doesn't exist. If it's a polynomial, it always exists. Then you find the y values for all of those. Plug back into the original function. Make a table. It's kind of hard to say the word function when you're sick. Function. You make a table, you figure out what the mid and the max is. Rolle's theorem. Rolle, rolle, rolle. Rolle's theorem and MVT, we're going to talk about those. Rolle's theorem helps us know that there is a min or a max. In the interval, derivative equals 0 at one point in the interval. That's what we're able to know for that. And the conditions for rolls is that f has to be continuous on the closed interval a to b. It has to be differentiable on that same interval a to b. We say open though for that always when we're talking about differentiability. And f of a equals f of b. If that's the case, the derivative must equal 0 at one point within that interval. MVT is rolls is a version of MVT that's specific, but MVT is just basically the same conditions, but this one doesn't have to be true for that. Instead, this is how we're able to know that the slope equals the derivative at one point. All right? Now, first derivative test. When we're doing a derivative test, same thing with second derivative test, what we do is we figure out, okay, where are the points where something changes? That's just random. And you figure out what it's doing in between those. And so we're saying, oh, we're going from increasing to decreasing. So that means we're going increasing to decreasing. That means, oh, there's a maximum there. Oh, there's a minimum there. That's what the first derivative test is. And then concavity, second derivative test, you can use that too. Curve sketching. Already made a video talking about curve sketching, but you're going to just want to make sure you find everything you'll need to have: intercepts, asymptotes, derivative, second derivative, points of inflection, mins, maxes, etc. And then, yeah. Next thing we'll talk about displacement versus distance traveled. Displacement, distance traveled. Displacement, so a good way to show is like, let's say we start here. We go 8 meters to the right, and then we go 4 meters back. Displacement is 4, distance traveled is 12. That's the best way to explain it. If you go in the negative direction, it subtracts for displacement, but not for distance traveled. Now, even or odd functions. Even function is symmetrical over the y-axis. So that means that every negative thing that would be negative ends up being positive, or vice versa. Odd is symmetrical over the origin. So for every positive or negative x, there's also positive and negative y. Optimization, I have a video on that already, but that's where we're trying to, how can we minimize or maximize area or volume or something like that? And you basically end up just finding the critical values to figure out a min or max that tells you that. And there you go.